Hello everyone, in RxJava free tutorial. In the previous video we are talking about filtering operators and conditional operators in RxJava free. In this video we will be discussing transforming operators and also operators with which we can combine different observables. If you would like to see operators which we use for creating observables, check my previous video, the link is in the description. Okay, let's get started. We start with transforming operator called map, and this is basically most widely used operator in RxJava free world and in RxJava in general. So in my case, I am emitting number 1, 2 and 3 as an items, and I'm using map operator in order to change type of this emission. So in this case, what I'm doing, I'm basically transforming this 1 to 3 to the string. And as you can see, this is printed to the console. Not the actual integers are printed to the console, but the strings of these integers. And this is basically what map does. Later we have sorted. Sorted is basically the best operator you can use when you would like to sort your items before the emission. And for example, as you can see here, I'm using sorted without any parameters. And this is basically for this very simple scenario. But if you would like to sort some custom objects that your observable emits, you need to use overload function of sorted, and you need to pass comparator object here. Then we have scan. Scan is basically very specific operator. It is very useful in case you would like to, let's say in a simple way and in a quick way, sum all items which are emitted by observable. So let's describe how it actually works. As you can see, scan takes two parameters. Accumulator, which represents all the previously emitted items, sum of it, and item, which is basically the current item of emission. And what I'm doing here, I'm returning from this function sum of accumulator and item. So how it actually works? Let's say that number 1 is emitted. In this case, accumulator is 0, item is 1. So this actually returns 0 plus 1, 1 is printed to the console. In the second iteration, our accumulator is 1. So here we have 1, the current item is 2, accumulator plus item equals 3. So our accumulator equals 3. In the last iteration, our accumulator is 3, current item is 3, so accumulator plus item equals 6. As you can see, this is quite specific, and I believe that you will find some scenarios when it will be actually useful for you. Then we have buffer. Buffer is actually very handy when you would like to emit items in chunks. So I'm using range operator here, starting from 0, and I'm emitting actually 10 items, up to 9, from 0 to 9. And I'm introducing buffer of 3. This means that our items will be not emitted one by one, but rather in chunks of 3. And this is what actually happens here. As you can see, my items are emitted as a list of length 3. So firstly we have list of 0, 1, 2. Here we have another list, and of course the last item, which is 9. Group by is useful operator when you would like to group some results by some property. Let's describe this with this example. So as you can see, I'm emitting items, actually 7 items, AA, BBB, CCC. And I would like to group that emissions by string length. What I'm doing, I'm using group by operator. I pass the function, and this is basically the function which represents by what you would like to group your items. And I'm telling that I want to group by item length. So as you can see, actually my group by operator caused that I have 3 groups. First group with strings of length 1, second group with strings of length 2 and the third group with the strings of length 3. And what this flat map single is, basically it is used for you so results are, let's say, nicely printed to the console. Without this it would be hard to show you how actually group by works. Basically we usually use these two operators together. So remember, if you would like to group by your emissions, your items which are emitted by some observable, use group by, and of course you can group by whatever property you want. Flat map, this is basically similar to the map, but what map does is basically transform one type to another type. In the previous example we mapped from integer to string, but flat map always need to return from the function observable of some type. So for example, here we pass 1, so it is integer, but we actually returns observable of integer. And this is useful if you would like to do some asynchronous operator in the stream. I'm not going into the details right now, but you can find some nice examples on the internet. So remember, you can use flat map when there is some asynchronous operation basically in the stream. It can be, for example, I don't know, some request or whatever you like. And the last one, transforming operator to list. Very simple. If you have some emissions from observable and you want to, let's say, create single emission of this and transform it to list, simply use toList operator. Now let's discuss operators which are useful for combining observable. We start with merge with. Merge with works in that way it combines two observables. Let's look at this example. Here we have one observable which emits items 1 and 2 and another observable which emits 3 and 4. As you can see, our both observables are merged, and actually all the items from one observable and second observable are printed to the console. And what you can actually spot here is that items from second observable are emitted after items from observable 1. And this is not always the case. Basically all depends from the type of the emission. I am on ReactiveX official page where merge is actually explained, and as I have shown you in my example, items from source number 2 were emitted after items from source 1, but this is not always the case. As I said, all depends from time of the emission. So as you can see in this example, actually items from source 1 and items from source 2 during merge are interleaved. So they are not, let's say, divided by two different chunks, but items from source number 1, let's say, are mixed with items from source 2. And this is because items from source 1 and 2 were, let's say, emitted around the same time. For example, if in source 2 items are emitted later, this is looking exactly as I shown you in my example. But in this example here, the items were emitted earlier in source 2 than the last item, for example, from this observable 1. Then during the merge, that's why these items like this one and this one are before last emission of observable number 1. And the last one we are going to discuss today is zip with. Basically, it is an operator that allows us to combine one item from one source and second item from another source and produce some results. So here I have two observables, one emitting items A and B and second emitting items C and D, and I'm using zip with operator. So I'm zipping observable 1 with observable 2, and what I need to pass to the zip with function is basically a function which represents the final result of zipping. So in my case, my, let's say, final result is basically a string which represents item 1 from source 1 and item 2 from source 2 as a string basically next to each other. So as you can see, what this actually does, it is printing the results. Item AC, so we zipped this item with this item, and the second emission is item BD, we zipped this item with this item. So this is basically how the zip with works. And actually you can zip with more than one observable. If I remember correctly, there are like up to 9 or even more observable which we can pass to zip with, and we can actually have some results from zipping all the items coming from all the observables. Alright, in this video we described transforming operators, operators for combining observables, and as I said, if you would like to check operators for creating observables, please check a link in the description under this video. And in the next video we'll finish operators thing and we'll discuss utility operators and error handling operators. Thank you for watching today's episode and see you soon. Bye.